All right, guys, so now we're doing section 4.5, and this is April 14th. Halfway through April already, wow. Okay, so we're going to be graphing rational functions today, and in general, a rational function is a function that can be written in the form p of x over d of x, where p of x and d of x are polynomials, okay? And we'll talk about how to use those polynomials to help us find parts of the graph that are important. Okay, so vertical asymptotes, so it's one of the important things. Because we have a rational function, we have a denominator. So whenever the denominator equals 0, we know that's undefined. So that's what creates our vertical asymptotes, and that's what this is saying here. So whenever the bottom is 0, we're going to get a vertical asymptote. Find the vertical asymptotes of each function. If they exist, then state the domain of the function. When really the domain is going to be all real numbers except those asymptotes, okay? So down here, x squared minus 1 on the bottom, that factors to x minus 1, x plus 1. So your vertical asymptotes, or whatever, make the bottom 0. My vertical asymptotes are at x equals plus and minus 1. And so my domain is going to be all real numbers except for positive and negative 1. Okay? Over here, x squared plus 1. Well, in the real number system, can I make that 0? Right, I have to think of a number that's squared as negative 1, and that the only number that works for that is I. I isn't in the real numbers, so find vertical asymptotes. There are no vertical asymptotes for this one. So my domain for that one is all real numbers. C, can I factor this? Are there numbers that multiply to 3 and subtract to 2? There are. Okay, looks like that. And so what makes the bottom 0? Either a negative 1 or a positive 3. So those are my vertical asymptotes. X equals negative 1, x equals positive 3. So your domain is going to be all real numbers except negative 1 and positive 3. And then down here, this one's pretty straightforward. The only thing that makes the bottom 0 there is negative 1. And so you're going to have a vertical asymptote at negative 1. Okay? And your domain is going to be all real numbers except negative 1. Okay? All right. Horizontal asymptote's a little trickier. A horizontal asymptote is dependent upon the degrees on the top and bottom. So if you've got an ax to the n on the top and d is bx to the m. So the degree on the top is n and the degree on the bottom is n, or m, sorry. If the degree on top is less than the degree on the bottom, so x over x to the 4th, that kind of thing, then you have a horizontal asymptote at y equals 0, which is just the x-axis, okay? If the degree on top and bottom are the same, then you can divide the leading coefficient, a divided by b, whatever fraction or a rational number that is your horizontal asymptote. And if the top has a degree bigger than the bottom, the graph has no horizontal asymptotes. They have oblique asymptotes, and we'll talk about that a little bit later on. So, locate the horizontal asymptote for each function if one exists, then determine if the graph will cross the asymptote. We're going to graph it on the calculator to help us determine this. So, here the degree on top is 1, x to the 1st. The degree on the bottom is 2. And since the degree on top is less than the degree on the bottom, your horizontal asymptote is y equals 0. Okay? And so, let's grab your calculators. We're going to go ahead and graph 3x over x squared plus 2. And we're just trying to determine if this crosses the x-axis anywhere. Okay? My graph clearly does, so then determine whether the graph crosses the asymptote. Yes. Okay? Part B, the degree on top is 2, the degree on the bottom is 2, x squared over x squared. They're the same, so I divide my leading coefficients. 1 divided by 1, y equals 1 is your horizontal asymptote. Now again, do we cross that line y equals 1? Well, we need to graph the function to figure this out. So x squared minus 4 over x squared minus 1. Hit graph quick. And in my graph, we do not go over the line y equals 1, so I'm going to put a no for that one. All right? Down here, the degree on top and bottom are the same again. They're both 2's. 3 divided by 1 is 3. Y equals 3 is your horizontal asymptote, so we're going to go into here. Again, 3x squared minus x minus 6. And then on the bottom, x squared plus x minus 6. Go ahead and graph those in your calculator. Again, trying to see if it crosses this line y equals 3. And if you're not sure, in y2, just go ahead and graph y equals 3 once and see if it crosses that. It definitely does. So we're going to put a yes on there. And that we can just determine from our graph, you guys, okay? All right. Guidelines for graphing rational functions. So if I ask you to graph this whole thing, we've already seen a couple of them on the calculator, what they look like. Here's the steps that I would apply. So find v of 0, which is your y-intercept. In other words, just put a 0 in. See what you get. Put the dot on the y-axis where that occurs. Find the zeros of p. So where's the top 0? That's going to be the x-intercepts. Where do we cross the x-axis? Find the zeros of the denominator. Well, we said that's going to be where our vertical asymptotes are. So we're going to draw those in. Locate any horizontal asymptotes if they exist. Determine if the graph will cross the horizontal asymptote. We'll look at our calculator to help us with that. And then put a few more points on there to give us an idea of what that graph looks like. Okay? So, graph the function. So the first thing we're going to do is we're going to put in a 0. Okay, so that gets rid of all the x's. Negative 6 divided by negative 6 is just 1. So that's going to be my y-intercept. Okay? And then what about the top here? So factors that multiply to 6 and subtract to 1. So I think we have x minus 3, x plus 2 here. Okay? Well, that means we're going to cross at 3 and negative 2. And those are going to be my x-intercepts. Okay? Vertical asymptotes. Well, the bottom here factors to, well, again, multiply to 6, subtract it through. This is going to be x plus 3, x minus 2. So there's a vertical asymptote at negative 3. Okay? And another one at positive 2. Okay? So now we've got that taken care of. Horizontal asymptotes. The degree on top and bottom is the same. So I can divide the leading coefficient. 1 divided by 1 is 1. Okay? So we're going to have a horizontal asymptote here at 1. Okay, so we're starting to get a little bit of a picture of our graph. The rest is going to be plotting points, you guys. Okay? So we're going to grab our calculator. We're going to go into our y equals. And x squared minus x minus 6 on top. And on the bottom, x squared plus x minus 6. Okay? And so my suggestion to you is to go into your table, and then we're going to plot some values on either side of the asymptote. So here we've got an asymptote at negative 3. So I'm going to look at negative 4, for instance. That gives me 2.33. Okay? Negative 4, 1, 2.33 or so. Negative 5 is at 1.7, so we're getting closer. So I know that we're going to have a branch like this. Okay? Now between negative 3 and 2. So negative 2 gives me 0. We already have that point. Negative 1 gives me like 2/3, getting close to here. Positive 1 gives me 1.5. Okay, positive 1 gives me 1.5, which means we've got that scenario. And then we already have what's happening at 3. We can look at 4 if we want one more point. And we get like 0.4 when we do that. Okay, so I know now we've got something like that. You can hit graph on your calculator to kind of double check that, to make sure that that truly is what our graph is looking like. okay? But that's really the process, you guys. Go through those steps, follow those guidelines. Where do we cross the y-axis? Where do we cross the x-axis? Where are my vertical asymptotes? Where are my horizontal asymptotes? And then be sure to pick points on either side of those vertical asymptotes to graph, okay? Sure enough, I got the same graph on my calculator. All right, use the graph of f of x shown to construct an equation. All right, so now we got to think about this a little bit. I've got vertical asymptotes, it looks like at -2 and +3. So I've got that scenario, okay? We cross the x-axis at -1 and 4. Okay? And, you know, we can do a little bit more work here. It looks like we can guess our horizontal asymptote a little bit. What I really don't know is I'm going to put an A up here because I really don't know what's out in front, you guys. Okay? So my job, if you look at example 4 in the book here, they also give you the point 2, 3. Okay? So they're saying we definitely cross at this point 2, 3. That's going to help us determine what that A is. And once I determine that, I'm good to go. So let's refresh. I got these because this is where my vertical asymptotes were. Okay? And the vertical asymptotes occur where the bottom is 0. So we had a vertical asymptote at -2. So -2 would make that 0. And another one at 3. Okay? That would make that 0. Okay? And then these two factors came where we crossed the x-axis. We crossed the x-axis at -1, so x plus 1 must be on top. And at 4, so x minus 4 must be on top. So now we're going to put a 2, 3 in. So on the left side, I'm going to get a 3. And then when I put a 2 in here, 2 plus 1 is 3, and 2 minus 4 is -2, so I'm going to get times -6. And on the bottom, 2 plus 2 is 4, okay? And 2 minus 3 is -1, so I'm going to get a -4. So I've got 3 equals 3/2 A. Multiply both sides by 2/3 and I get A equals 2. And so now if you just put that 2 back into here, okay, and then I'm going to multiply that out. So I've got x squared minus 4 plus 1 minus 3x and then minus 4. And then on the bottom, multiply that out. X squared minus 3 plus 2 is minus x and then minus 6. Okay? And so that's kind of where I'm going with this. So you gotta work through the process, you guys. I get these from where the vertical asymptotes are. I get these two from where we cross the x-axis, and then I picked another point to help me find what kind of stretch or shrink I did, and then I just need to work it out. Okay? All right, oblique and nonlinear asymptotes. So if you have that rational function, if the degree on the top is bigger than the degree on the bottom, you're going to have an oblique asymptote. Okay? And you can find those out by just dividing the top and bottom, and we'll do that in a second. So the degree on top, x squared, is bigger than the degree on the bottom. So using synthetic division, 1x squared plus 0x plus 0, and divide by 1, because we have an x minus 1 in the bottom, 1 would make that 0. Okay? So bring down the 1, multiply, add these up, multiply. Okay? And so I'm not concerned with the remainder at all. What I have left here is x plus 1. X plus 1 is my oblique asymptote. Okay? So y equals x plus 1 crosses the y-axis at 1 and has a slope of 1, up 1, over 1. Okay? Down 1, over 1. Okay? So I'm going to throw that in there. There's my oblique asymptote. I have a vertical asymptote at 1 because that's going to make the bottom 0. So I'm going to throw that one in there, okay? We're gonna cross the x-axis at 0. And of course, that's our y-intercept as well, okay? Well now, once I've kind of gone through those guidelines, my job is to put this in my calculator, and I need to plot a few points on either side to see what I'm getting. So let's go ahead and put this in. So the numerator is just x squared, and the denominator is x minus 1, okay? I'm gonna go to my table. My vertical asymptote was at 1, so I need to pick points on either side of it. So when I go left of 1, we know 0 was 0. Negative 1 gives me negative a half here. Negative 2 gives me negative 1.3. Okay? And so I feel like if I keep following this, we're going to follow that oblique asymptote, and then we're going to cross there as well. Okay? So then let's pick some points to the right of 1. Okay, so 2 is at 4, right here, and 3 is at 4.5, okay, etc. Okay, I got 4 to be at 5.3. We can keep plotting these points if we want, but I should get my graph inside of here following those asymptotes as well. So I'm going to get that scenario right there. And you can double check on your calculator if you want. Calculator's not going to draw in the asymptotes for you, but it should look a lot like that when it's said and done. So, again, where does the top 0? At 0. That's where we cross the x-axis. Where is the bottom 0? At 1. Vertical asymptote. There were no horizontal asymptotes, so I had to divide, get x plus 1. That was my oblique asymptote. And then I went ahead and plotted some more points, you guys. Just use my calculator to help me get some points and graph it from there. All right? So I think we're going to stop there. Good luck. Do the assignment. Get them in by the day of the test so we can stay caught up.